Hey there, so we're going to talk about constant velocity. And so before we get too far with constant velocity, let's first just look at this word velocity. And so if I defined velocity, it would just be an object's change in position. And another word that we use for that is displacement, right? An object's displacement or change in position over a period of time. And that's a basic definition of velocity. Now, a lot of times, velocity it's confused with speed. Okay, so velocity is not speed. They're different. Velocity is what we call a vector quantity, whereas speed is what we call a scalar quantity. And if you've ever watched the cartoon The Incredibles, right, there's a villain on there, and his name is Vector. He says he does crime with both magnitude and direction. And that's what a vector quantity is. It includes the magnitude and direction. A scalar quantity is just magnitude. And a simple example is if I say I'm in my car and I'm driving 10 meters per second, and that's all I say, I'm talking about the car speed, how fast it's going. And if I say I'm going 10 meters per second headed east, I've now included direction, so that is the object's velocity. And so that's the difference between speed and velocity. Now for velocity, we use the symbol v, and we have a simple equation here for velocity, and it's really just this definition that we said. It's object's change in position. We said that's displacement, and displacement is this delta x. That's your change in position over a period of time, and that's delta t. So here's a basic definition to calculate velocity. Now throughout the year, we're going to have several different equations that incorporate velocity, but this is just the basic equation in calculating velocity. And if you remember from some of these graphs that we've been doing, we said that displacement, right, was measured in meters and time in seconds. So the unit for velocity is meters per second. Okay, that's going to be my unit for velocity. Now let's look at a real easy example here, and this will kind of help distinguish the difference between speed and velocity as well. So let's say I'm sitting here in the classroom, and over here I got the wall, and let's say that the wall here, it's about 10 meters away. Okay, so that's kind of far. Let's say 5 meters, 5 meters away. And let's say that I run as fast as I can to the wall over here, and let's say it takes me 5 seconds. Okay, so the time it took me to go from there to and run 5 meters, it took me 5 seconds. So if this is my starting position right here, so I'll call that position 0, 0 meters, and this position over here would be 5 meters. And then my time was equal to 5 seconds. And I wanted to calculate both my speed and my velocity. Well, my velocity would be equal to my displacement over time. My displacement, my change in position, is my final position, which is 5 meters, minus my initial position, which is 0 meters, all over that time period of 5 seconds. So my velocity would just equal 1 meter per second. If I wanted to calculate the speed, okay, so speed is equal to your distance over time. Not displacement, but my distance. And so my distance that I traveled was still 5 meters, right? So the speed would equal 5 meters over 5 seconds. That's just 1 meter per second. That's the same. Well, you might be saying, well, what's the difference? Well, let's say now I run to the wall and back. Okay, so calculating the velocity for that, it's my change in position. So if I ended where I started, my final position would be 0 meters. My initial position was 0 meters over a period, let's say it took me 10 seconds, right? Over 10 seconds. Well, my velocity was 0. And the reason why is because I ended where I started. But if I calculated the speed, my distance, I went 5 meters, and then I went another 5 meters. So my total distance that I traveled was 10 meters, and it took me 10 seconds. So my speed is 1 meter per second. So this is why, or where the big difference is between speed and velocity. Velocity depends on direction, whereas speed does not. Okay, so that's a basic equation for calculating velocity, and that's the difference between speed and velocity. Now we also have to be able to represent velocity graphically. So there's several different ways to represent velocity. One is with a dot diagram. So let's say that you're driving your car. Okay, I'm not very good at drawing. Okay, so here's a car, and let's say it's got an oil leak. Okay, and the car's driving real slow, and it leaves a drop of oil as I'm driving and kind of coasting down the road. And so what it would look like if this car was traveling at the exact same speed the whole time, and the oil drip was happening at the exact same rate, I'd end up with a dot diagram of something like this. Okay, so sometimes we'll see these little dot diagrams. I've seen them where they look like this. Okay, and so if I look at the spacing in between all those dots, it's the exact same, right? And the reason why is because this car was traveling the same speed, and then the rate of that oil drop was the same. So I have this even spacing between these. And that would represent a constant or same velocity. Okay, so that's one way we can see a representation of constant velocity, okay, staying the same. Another way is with our position time graphs. Okay, we've been graphing and we've been making these position time graphs. So if we make one real quick, this would be time in seconds. This would be position here in meters. And if I was to graph some data, let's say here, 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 and we made a best fit line, and looking at this one here, we notice that it is a linear line. All right. One of the things that we did with our graphs is we would find the slope, right? The slope was equal to your change in y over your change in x. But we also learned how we can substitute those variables for y and x, right? So for this graph, the y-axis is displacement, the x-axis is time. If I plug those in, that means that I would be having delta x on the top, and I would have delta t on the bottom for the slope. let's go back up here and look at our equation for velocity. It's delta x over delta t, which is exactly what we have when we found the slope of a position time graph. So when you have a position time graph and you find the slope, what you're really finding is the object's velocity. And if we have a linear line, that means that the slope is staying the same the whole time. And if the slope is staying the same the whole time, that means my velocity is staying the same. So a linear line then means that we have a constant velocity. Again, this is with a position time graph. That's why it's so important to label our axes here. Okay, so this is in dealing with a position time graph. When you find the slope, you're going to find the object's velocity. And if that's a linear line, the slope isn't changing, so you have a constant velocity. Now, sometimes, and we'll get into this a little later in the year, you won't have a linear line. Okay, you might have a line that curves. And when a line is curved, that is a nonlinear line. And a nonlinear line means that your slope is changing. Okay, so that would mean that my velocity is changing if we're talking about a position time graph. Okay, but we'll get into that a little later and we'll get in more depth with that. For now, we just need to know that a linear line means a constant velocity when we have a position time graph. Now we also could have, draw a line here, a velocity time graph. So we can have a position time graph and we can have a velocity time graph. So if we're talking about constant velocity, right, this is what we're kind of worried about right now. A constant velocity on a velocity time graph, it's not going to be a linear line. Okay, rather, it's going to be just a horizontal line. Let's say this was 4 meters per second, right? Here's 0 meters per second. And let's say here's 1 second, 2 seconds, 3, 4, 5, 6. And so as time goes on, the velocity is staying the same, right? It's at 4 meters per second. So over a period of time, the velocity is not changing. So a horizontal line on a velocity time graph means we have a constant velocity. Okay, so the word constant means it's staying the same. And you need to be able to distinguish the difference between a position time graph and a velocity time graph and identifying if the object has a constant velocity or not. Okay, and the way to do that, if it's a position time graph and it's a linear line, then that means it is a constant velocity. If it's a velocity time graph and it has this horizontal line, that means it's moving at a constant velocity. Okay, and we also need to remember for a position time graph, our slope, okay, this is important, our slope will find the velocity of the object.